Hey, hi everyone. Good evening.
Yeah, hi bro.
Hello, hi, Raju here.
Hey, hi Rajiv. Just we will wait for another 2 minutes and we will start the
Hello,
session.
hello.
Yeah. Hello. Hey, hi Rajiv. Yeah, we will begin the session just in next 2 minutes. We are just waiting for audience.
Hello, am I audible?
You are. Hey, Tapash, am I audible?
Yeah, you are
Yeah,
audible. I
am I
think.
audible? Raju here.
Not sure if he can listen to us.
Okay.
Hey, this is Vijaya. Am I audible?
Yes, yes.
Yeah.
Your voice is breaking.
Hey, Raju. It's audible to other audience. Please check your network and probably come to the area wherein like you have a good network. Okay, it's 5 minute past, so we'll start with the presentation today. We'll begin with the course. Let me share my screen. Just a second. There is some issue in sharing screen. Hey, hi everyone. Can you see my screen?
Yeah,
Just a second. Anyone from EdYoda here? Just a second. I am not able to see the screen. Just a second. Hi team, am I audible now?
Yes.
And you can see on the slide in the full
Yeah,
mode.
we can see.
Okay, great. And sorry for delay. This is first session and little bit I'm stuck with some of system related issue. So let's quickly start with the session. Quickly, I will try to introduce myself. My name is Sanjeev and I have 20 plus 20 plus years of experience in IT industry and had worked for multiple different domains, specifically in investment banking and commercial banking sector, along with healthcare and insurance domain. So that's a brief about myself and had a deep experience in creating system architecture as well as solutioning from scratch for enterprise level software. Yeah.
Hi, Sanjeev,
So
your voice is breaking.
is it breaking for everyone or just for
No, it is not
Raju?
No,
breaking. It
it's
is
not
clear.
break.
Hello,
It's not.
Sanjeev.
Faraj, it's fine.
Raju, it's just probably just check at your end. Could be a patchy network. Yeah.
Hello.
Yeah, Raju, it's a patchy network at your end. Other are able to listen and they are able to hear me clear and loud. Okay.
Okay.
So we
But
will,
sometimes your voice is chopping.
yeah, that's because there could be a network lag at your end. So I've just confirmed with other audience. So
Okay.
they are not facing similar challenges.
Okay.
Yeah.
Okay. Okay.
Okay. Okay. Let's start with the presentation today. Yeah. So once again, welcome everyone. So this program is not about learning how model works. So let me set up set the expectation from this program. So it is about architecting AI system that survives reality and production load, compliance, budgets, and board level scrutiny. I hope you understand even like a scrutiny we go through or audit we go through for our uh, enterprise level software, right? So in every organization, there is a scrutiny at a board levels. So, and those are a compliance requirement. By the end of this course, your thinking should shift from, can we build it to should we build it and how and at what risk. Yeah, so rather than can we build it, should we build it, we should also focus on risk and compliance. So we have to think from like a holistic perspective. Yeah, just a second, I will just look into, just give me 1 second. Yeah, that's fine. Just give me 1 sec. Yeah, we are good. Okay. So I was talking about like by the end of this course, your thinking should shift from can we build it to should we build it and at what risk? So it's not only about like solutioning, but rather you have to think from the holistic perspective. Yeah. So this is the AI solution architect mindset, owning the value as well as risk and system integrity. The landscape of the artificial intelligence has fundamentally shifted. If you talk from the to, to, to 2010 and the way we are now thinking for the AI space has drastically shifted. It has shifted saying like Now we are more concerned on like owning value, risk, and system integrity. We are not just considering about fine tuning of models and just ensuring that it solves some of the problem rather than looking from risk perspective and system integrity. The landscape of artificial intelligence has fundamentally shifted, and we are moving past era of like experimentation into the era of industrialization. And that is where this course is specifically designed for senior professional, those of you with 15 plus years of experience and who are ready to bridge the gap between technical expertise and high level business strategy. Our goal today is to help you master the role of AI solution architect and understand how to architect enterprise grade system that are reliable as well as secure and value driven. So that's the overall goal. It's not about we will not talk much about the models, but rather than how can we use the existing AI tools framework to design as enterprise grade, you know, uh, software. Yeah. So this is a first session is you can like we'll keep it very light. We'll not talk much deep into all those, but it's a mostly like an overview of the upcoming session. We will just touch base some of the part, and I hope every one of us has gone through all the modules of each session, right? So you can see, do you guys want me to go through the modules and scan through, or you have already gone through them?
It would be better if we can scan through the modules because I haven't
Yeah.
gone through it.
Yes, yeah, this is a first session, so I thought if all of us have not gone through, let's probably we'll skim through, we'll not go into detail, and it is at your disposition, wherein you can always go through after the session. Yeah. So if you'll just open this one. So if I just go to like EdYoda classroom session, you can see my screen, guys, right? I will keep on asking from you whenever I shift my screen. So I'm at like AI solution architect curriculum space model level. So I'm at a page model overview, and now I'm at a page curriculum. It's loading. You can see the curriculum now. How many of us can see?
Yes, I can see.
Everyone?
I
Okay,
can see
great.
it.
Yeah.
Yes, yes, I can
So
see.
so these are left hand sides are like these are the session. Yeah. And these are the subtopics which we'll be covering on the session. So first session is all about foundation of AI solution architect role, where we will discuss about what is the role and what are the ROI, some of the aspects, how we should think about like as a while we are wearing the hats of AI solution architect. So thought process, it will be a paradigm shift once we finish the session, the way we should think from the solution architect perspective, not just from the engineering perspective. Yeah. So in this we will be discussing about evolution of AI role, responsibility, deliverables, stakeholder management, translating business need into AI technical solution, AI project life cycle, KPI, ROI, SLA. I hope you guys understand about KPI, return on investment, SLAs. Yeah. These are the industrial terms, common architect archetype and solution designing patterns, uh, and skill matrices and career roadmap. And we will this will be mostly overview, and in the next session then followed by detailed discussion on all the topics which we'll skim through today. Second session will be about the business strategy, scoping, and AI road mapping. Yeah, so subtopic will be, identifying and prioritizing AI opportunity within organization, business case development and ROI analysis initiatives, stake alignment and communication framework, and at the end of this session will be risk compliance, ethical trade-off, and decision. And each of the so I have ensure like at each of the subtopics we talk about uh, some of the real world like examples. And after each of the two session or three session, we will collect together or collaborate together all the learnings which we have done in the session and try to use them to showcase one of the like a real world problem statement and how we solve them using the concept which we have learned in, say for example, past 3 or 4 session. Yeah, so mostly it will be practical oriented. Whatever experience I have so far gained, I will try to put in the detail and try to understand and try to be, like at the end, we become an enterprise level architect. Third session will be about data strategy, engineering, and governance. I will not go much into this detail, and it is more about data profiling, sanitization, validations, governance, scoping and all, and guardrails, very specific, yeah, audits, feature engineering. You can say reusable feature patterns in case of a data uses, privacy compliance and data security best practices we will discuss in this session. Yeah, third session is more on model designing, LLM and evaluation framework, so wherein we will discuss about model taxonomy, machine learning, DL foundation model, so some of the models which are used and which kind of models to be used in which kind of situations, LLMs versus RAG. So we will discuss more in details like what is RAG, what is LLM, and when in which scenario we use which kind of like model selection criteria. We will learn about them, evaluation methods, offline matrices, model optimization, explainability and bias. So SHAP, lime and fairness matrices, these are some of the matrices we use in our AI systems while we design them or while understanding the model. Yeah, so you can understand like from like this is a mix of like if I would say management, stakeholder management, plus like engineering best practices, and in both of them how we fit the AI. Yeah, so you should have a good understanding of AI. This course is not about like uh, individuals should know at least, I would say, some level of AI understanding of the model, because we will not teach much detail on the models, but rather in which kind of situation which models to be applied, how architecture will be. Yes, you should have a good understanding of at least system design. Yeah, so in system design how we will put AI, in which kind of situation AI will work. Yeah, fourth is about like this is a fifth one. Yeah, fifth one is AI system design and architectural common pattern enterprise distributed patterns which can be used. Yeah, so we will discuss about them with some example. And from this session onward, there will be more and more practical example will be added, because still here like till the model design and all evaluation framework, this is more on like a theoretical come like a management related. Yeah, wherein you should understand all this theory and you should understand ROI, SLA, SLO and all. But after this one is like mostly on the practical designing, how we will do those practical, and both aspects of uh, AI solutioning are very important. Stakeholder management, you have to understand stakeholder, as well as you should understand and deep on your solutions system design as well. and how to collaborate among the different. We will talk about the first session itself, who all are stakeholder, how we try to differentiate between scopes among them. Yeah. Infrastructure, compute, and cloud foundation. I will take some example of AWS here, and at the end of the session, final session, we will talk about the multi-cloud deployment as well. Yeah. So we will talk about like infrastructure, like best practices and design patterns in infrastructure as a code also we will talk about. I hope few of us would be knowing about infrastructure as a code. You can write an infrastructure using, like some of the programming languages supported by some of the frameworks. ML, continuous delivery and AI. So this is more on like a continuous delivery and ML ops. So DevOps, basically we will talk about how to do the DevOps. And in DevOps, we will include CI/CD, observability. So, and we will discuss about using some of the example in there. Yeah. So most of the session will be, each of the session, as I said, like from, AI system design onward, every session will have some architecture, some practical example wherein we will try to, like talk about how each of the concept we have learned should be added. Yeah. We will try to keep the concept generic, but like there will always be a, like a little bit change in the concepts depending on the systems or domain wherein you work with. Yeah. uh, Third last is responsible AI. Mostly it's talk about compliance and governance. And final will be, as I said, like multi-cloud AI architecture. We will talk about how we can, we can solution for multi-cloud system. Yeah. And final will be, business enablement, scaling, and capstone project. Yeah. So this will be more on the business enablement and scaling. Yeah. So this is about the course. Yeah. So today is only about mostly we will talk about, yeah, overview of the all forthcoming session. So till now we are good. I hope we are able to skim through and able to understand what we will learn from the session. Yes. Great. I will let me go back to the session now. Yeah. So what is time? We have already reached 28 minutes. So I will try to expedite now, yeah, a bit. And let me know if you guys feel anytime like I should repeat it. Yeah. Okay, so course overview and learning objective. We have talked and skimmed through. I think we can skip this part, but I will talk about, like this competency matrices and career. Yeah. So as I said, like this course bridges a gap most organizations struggle with. Let me do F5 here. Just a second. You guys can see my screen, right? Just a second. Yeah. Okay. So as I said, like this course begins with a bridging the gap most organizations struggle with. Like most of the organization, if you see, like they have a they come with, like they come with a brilliant models that never deliver the business impacts. Like they are more you would have seen in your day-to-day working as well. Many of us come with a brilliant model, but we lack somewhere, like business impact delivered by those models. So always we should think in both different origins. At the end, we are all here to solve business problem of the given organization. What we will cover is the full life cycle of discovery to operation, translating business strategy into AI architecture, modern patterns like RAG, agentic AI, hybrid edge cloud, and multi-agent solution as well. And most importantly, how value is measured and defended. You know, so we should always focus whenever we are solutioning or presenting to our leaders. We should always talk more about what is the value it is adding, and uh, what are the risk aspect. Let's be open about like a discussion. Yeah, try to uh, understand the problem statement from all the dimensions. Yeah. Now, if you look into the competency matrices carefully, notice something very important. Model are not the center. The center is, system design, governance, security, and business value. And this, if you think very holistically or understand competency metrics, this role naturally evolves into chief architect, because you are not solving the tickets, you are basically shaping enterprise directions. Yeah, which does not evolve on any of one, dimension. Not only, say for example, system design or risk, but it's a collaborative. Let's go to the next slide. Any confusion on this slide?
No.
All good, then we will go to the next. So I was talking about evolution of AI roles. So from 2010 to 2025, this is way, like each and every organization are looking for AI related resources. Yeah. So in 2010 till 2015, mostly we were hiring, or organization were having, data scientists who focus mostly on full stack analysis, experimentations. Yeah, so one person did everything. They uses mostly, notebook, dashboard, POC. They do the POC of the given small problems, but not looking from the enterprise perspective. So this is where, like a data scientist role has started. 2016 to 2019 was more on, machine learning engineers, wherein models which are generated by data scientists in previous, era, was then used by machine learning engineer and try to productionize them to solve some of the problems. Yeah. Key deliverables were API endpoints, Docker containerization, like to basically contain, to ensure like a Docker containerization. I think everyone understand. So basically your jars or EARs is then composed into the Docker file. Yeah. And Docker gives a, uniformity across, irrespective of, different environment or OS operating system nitty-gritty. So it's a label above the operating system. Training pipelines to train people, or to ensure more machine learning engineers are available. Yeah. Next, 2020, I would say like 2016 to 2020 is all about like, deployment of the models which has been generated, and, improve the models. Yeah. And uh, create the infrastructure wherein this model can run efficiently. So AI platform engineering, wherein, like infra as a code has infra as a code uh, is one of the practice we use. And it's not only for the AI, that's a general practice nowadays we use after the evolution of the cloud. Yeah, cloud services. Model registry, And you will see like there, I will talk about lots of AI tool at the end of the session, and that has been included as a reference architecture as well in your resource section, and wherein like if you go to there is a open router, there is a website called open router. I think more than at this moment, I think more than 550 models are registered. Yeah. Now 2023 onward is where like now people have started the n number of sufficient models. There had been CI/CD pipeline, all like maturity has been achieved, like those models were able to deploy in the production and had been tested across the multiple data set. Now it's all about how we can efficiently, or how we can use them to deliver day-to-day business problem. And that is where era after 2023 is more important from the AI architect perspective. Now in this era, you have to understand the business problem, whether like uh, is it like this problem statement is very can be achieved through just automation, or do we need a AI solution? So after few session, you will be able to understand in which kind of situation wherein you should apply the AI, you know, AI. Otherwise, you can do the normal automation as well. So this is where you have to understand between the rack. You have to understand agentic system. Also, while designing reliability, risk, and more important, return on the investment. And key deliverables here are, reference architecture, SLA, SLOs, yeah. So, and as well as NFR, non-functional requirement. We will go to the next slide. Yeah. So this slide is more on, like of how we can role is evolved from data scientist to a AI solution architect. Because in the previous slide you see that you can observe that the role has evolved from data scientist to AI architect. We will talk more detail in this particular section. So far, all good?
Yes. Yeah.
Okay, great. Okay, so this slide basically, this slide is, we can say like a philosophical shift between accuracy versus ROI, precision versus SLA, notebook versus runbook. Yeah, so that is where like you see like first step, data scientists were using notebook and all. They were doing the analysis. They were not bothered about like taking it to productionized some and solve the real world problem. Yeah. So this slide represents one of the most important mindset shift in entire program. Yeah. What you are seeing here is not a change in the job title, but it's a fundamental shift in how AI success is defined at an enterprise level. So we have to like think from a different mindset when we are trying to wear the head hat of AI solution architect. Yeah. The AI solution architect role exists because optimizing model alone, no longer delivers repeatable, scalable business value. This is the moment where, like AI moves from experimental to accountability. Yeah. So you are accountable. So as a AI solution architect, you are accountable, and you have to ensure, like your solution is it is scalable, it adds business value, it delivers some of the business value, it's giving a return on investment whatever your organization is putting in. Yeah. and moreover it's compliant, and it doesn't breaches the security or doesn't have any like risk to the organization. Yeah. So let's start with the traditional data scientist paradigm shift. So historically, the primary goal was, predictive performance and insight. Success meant improving accuracy, precision, recall, or F1 score. So F1 score, if you guys don't know, you can Google it. So it's one of the matrices in machine learning to understand accuracy of a model against a broader data set, and it basically includes is the precision and recall together. Yeah, the scope focused on model development and training. So I'm talking about like data scientist. Yeah, constraint were mainly data availability and data quality. Deliverables were typically notebooks, experiments, dashboard, and proof of concepts. All of this made perfect sense in analytics and experimentation era. So mostly, like first era was about like there was no model, and industry was also not very confident on like a AI way of working. And it's not like the AI has come after 210 or it just started in 210. AI was much earlier, but there were not much support, or there were not much, I would say, hardware support available at that time. That's why AI was not able to deliver whatever was theoretically like expected from the AI. But here is like enterprise reality. A technical excellent model can still be a complete business failure if it is not integrated, governed, and adopted or trusted. You would have seen in your organization in many of the situations, even like your particular solution or AI solution solve the given problem, that basically fails at the end because there is a risk posed, or there is no proper guardrails and all. And we will talk about how we should always consider those aspects or all dimension at the beginning, so that the engineering effort is not wasted into that. Now, contrast that with is a era where like a solution architect mindset. The primary goal shifts from model performance to system reliability and business value. The scope expands to entire end-to-end solution lifecycle: discovery, integrity, security, operation, and cost control. The constant are also changes. Instead of do we have clean data, the real constraint now become budget, compliance, security, latency, and enterprise integration. So I'll be repeating all these terms throughout multiple session whenever we are discussing on like some of the real-time example of solution design of a given problem statement. Success matrices generally includes return on investment, SLA, adherence, adoption. SLA, I hope you guys understand. Say, for example, if you are deploying an API has a SLA, or particular like a particular flow has a SLA. If it's a payment system, say for example, if you ask for deduct from your account, in how much time, max time, like my account will be debited and get credited to other. So there is always a max guarantee by a organization. This is the max time it takes Just a second. There is a call. Okay, so SLA adherence and operational stability. Accuracy still matters, but it is no longer sufficient. At this level, AI is judged the same way as mission critical enterprise systems. Now, the first major shift highlighted on this slide is, like a system integrity. Yeah. So this one is about the system integrity. We move away from optimizing, model matrices and towards ensuring end-to-end reliability, predictable latency, scalability, and resiliency. In production, failures rarely come from the model alone. They comes, mostly from integration gap, cost explosion, brittle pipelines. I'm talking about CI/CD pipeline or missing fallback logic in your system. So these are the terms probably you would have always heard when we discuss about, like a failure of a given prod deployed system. This is why, architects focus on how the system behaves under the stress, for which, you have to calculate NFR for the given solution or the system which will be implemented, not just how the model performs in isolation. So you have to always calculate NFR or system behavior under the stress, not in the isolation of its model with some of the small amount of data. Yeah. So this responsibility sits quietly with, AI solution architect. The next is, like third is, like product centric mindset. Yeah. The core question changes from, will this algorithm work, to will this solution solve the business problem securely, cost effective, and at a scale. What does that mean? This is often the hardest question, or hardest transition, because technical excellence alone is not uh, no longer, like a win condition. You have to think from your, different aspects as well. So as an AI solution, if you are creating an AI solution that improves, say, for example, matrices, but destroys trust of stakeholders, violates compliance, or exceeds budget, is not successful. Yeah. Regardless of how advanced model you are using. Have we understood this part? So deliverables. So if you'll see, like with the time, like the way we deploy our system has evolved from, like a waterfall model to DevOps model, wherein we are following mostly agile and delivering into, like bi-weekly. So we move from, notebook to POC to architectural artifacts. These includes reference architecture, inference contract, SLA, SLOs. Yeah. So this second part, if you'll see about, like prime release shift from, like a data scientist, success metrics, accuracy, precision, recall, it has shifted into, success metric, ROI, SLA, adherence, adoptions. Constant data availability, quality has been shifted to budget, compliance, and integrations. Yeah. So this is how, like some of the examples. One of the example, say for example, we can discuss it here, is, uh, banking system. In banking system, a data scientist might optimize a fraud model with excellence, AUC and recall. On paper, it looks good, but it looks as a successful, but in reality, the system fails if decision cannot be explained to auditor. Latency spikes during, peak hours, or PII handling violates risk policy. So mostly, we we have to think from different dimensions while we are solutioning or providing solution to any of the given problem statement. This is where, AI solution architect steps in and owns strict SLA, audit trail, governance, and kill switch based deployments. I think we must be using kill switch based feature. If you are deploying, should always use a kill switch. Cost controls. Yeah. Another example from the retail industry could be, I have added all these example in, your slide notes. So a retail wherein you try to distinguish between, like try to talk between accuracy versus revenue at a scale. So in retail, data scientists often celebrate a recommended model that improves click through by 3-4%. But like system fails when flush sale hits. You would have seen like cases of big billion day in Amazon or Flipkart. Service goes down, recommendation ignores inventory, or inference cost explodes during these peak hours. Similarly, I have added some of the example from other industry. So basically, like you should have a good domain knowledge, and you should always uh, try to try to always understand and write down detail about the edge scenario or different circumstances while solutioning your system design. Yeah. So I think many of us would have gone through the SaaS based platform. So mostly, if I talk from the SaaS perspective, feature matrices versus business matrices. In SaaS, AI features often boost engagement or time on feature, but they fail when inference cost grow faster than revenue, tenant impact each other, or premium customers see degraded performance. The AI solution architect ensure tenants isolation, quota controls, cost distribution, routing, strategy, and alignment with the price model. So key takeaway in case of a SaaS is, say, for example, AI that boost engagement but destroy, margin in technical debt, not innovation. So different industry will have a like a different so for AI solution architect should have a good domain knowledge on a given industry wherein you are working, yeah, along with the system design. Good you should have also like a leadership skill on stakeholder management. Yeah, you should define a different types of business matrices like and NFRs while talking or selling your solution to the leadership. So this is the comparison of roles. Yeah. So if you'll see, like there are 5 dimensions we have put in here: primary scope, deliverables, NFR ownership, stakeholder, time horizons. So AI architecture, if we talk from the AI architect, AI developer, and network architect. So for a given, like enterprise level software, all these 4 peoples are always involved, be it, agile way or waterfall way of working. Now, I think every organization follow agile way of working. But these are the all different, resources which are always, involved in your software implementation and design. So we have to basically, you should always understand the role clarity, which is absolute critical in, large enterprises. One of the biggest reason AI initiative for fail is, role confusion, people doing the right work but the wrong attitude. So this matrices compares four roles: AI architect, developer, engineer, network architect. And I want you to focus not on the titles, but scope, accountability, and decision ownership. Yeah. So let's start with the AI architect, because that is the role we are anchoring this program around. The AI architect owns end-to-end system integrity and strategy. This is not about writing most of the code; it is about designing this right system. Look at the deliverables: reference architecture, SLA and SLO, governance adherence, governance standardization. These are not optional artifact. They are what AI repeats. Uh, they are what make AI repeatable, auditable, and scalable, which I talked in the previous slide. Most important notice is NFR ownership. That is where you are the ultimate owner. Yeah. So AI architect is NFR is non-functional requirement like SLA, SLO matrices. If latency, reliable security, cost, or compliance fails, the AI architect is accountable. That is what it means with the NFR ownership. Yeah. So latency, it could be network latency related with the throughput, reliability, how system is reliable, security, is your system secure? Yeah. Or what are the guardrails to control different types of attacks, or at least some of the OWASP top 10 attacks? What are the cost? Is it cost very high compared to what it will deliver? And time in which the solution will be, can be implemented and ready to productionize. And fourth is, like a compliance. Yeah. I will skim through the other part, AI developer. So developer, they basically, given problem statement, they will try to understand and try to identify the model and API, and will do the implementation. Key deliverables are code, API, working models. They should, NFR is, they should be aware. So they will just go through the whatever solution you have designed. Stakeholder are basically, product owner, and QA is nowadays, in DevOps model, it's done by developer itself, or it is always automated now. Yeah. In architect, AI architect, we should please pay this very let's pay this part uh, with a very important, stakeholders. So here it's not only about uh, your department leaders, you know it there are other departments involved in organization. Those are legal, security, yeah, she should. So all these, basically, as a AI architect, you are impacting the organization. So you have to think very, very open mind and holistic perspective. You should not let any of, dimension to go in vain, or if there is a risk involved, we should always consider. And whenever you identify, say for example, even implementation is started and later phase, you have identified, raise the risk quickly. Yeah. So generally that is where, and this is about, designing an enterprise level solution. I'm not talking about day to day BAU task or small problem statement, for which also, there is always a architect, but we are talking about enterprise level solution. So time horizon generally is spent by AI solution architect is, you know, like 12 to 36 months. Yeah. Yeah. And remaining others developers is always two-week sprint. Developers and AI engineers, you can club it together. They work hand in hand nowadays in the same project. Network architect is another part. 3 to 5 years. It's talking about 3 to 5 years. It's about, you know, like decisioning and all. Whether we should go for a cloud base or having their own data center and all. But generally, once you have infrastructure is available, if it's all about like network designing or network architecture, it takes around 1 to 6 months, depending on the how big is your problem statement. So core responsibility of AI solution architect is reference architecture, defining standards and patterns for scalable, reusable AI system, tech selection, evaluation, and select the models, data strategy, designing robust data pipeline, ML ops orchestration, establish CI/CD for ML. Yeah, so generally you see like developer also do the CI/CD, but you know, like at the first hand you should always always create, you know, design for the CI/CD pipeline for your AI solution, and which kind of tools will be used. Yeah, so that, you know, quality of your software being delivered and security around the software which is getting created is never compromised. Security and compliance, which it's about embedded privacy, security control, and regulatory compliance into architecture by design. Cost optimization and performance. We should always talk about total cost of ownership, inference latency, system integration, integrating with the different system contracts. We will talk about different tools you can use for the API contract testing and all. So system integration is also very important, and what type of protocol will be used, you know, to integrate two different types of systems. KPI and SLA, define and monitor service level agreement, SLOs and error budget. We will talk more detail about this. This is one of the aspect in observability, and we'll talk more detail into that. Stakeholder alignment or stakeholder management. Yeah, so this is also very important. So you should be able to collaborate and understand the real business problem, even, you know, like a cost involved, and sometime, you know, like expectation from business is that if we are funding, we want at least solution, some part of solution to be delivered in phased wise, and how can we have some of the feature quickly onboarded. So you have to always talk in detail, or if there is a risk involved to achieve certain, you know, timeline, you should call it out and why there is a risk. Yeah. Continuous improvement, post, you know, like you have delivered a solution has been delivered to the production, how you will track the performance, how incidents will be managed, and drive iterative model for the improvement. Yeah. So I think all of, specifically in our organization now, you know, like everywhere we are looking from, you know, like automating all the different aspects. Yeah. And that is where AI has come into picture now. You know, in development, say for example, there we always, organization is trying to create, you know, like agent for developer, agent for QA, and developer can use, say for example, agent for QA, agent for developer to do the task, both QA and, you know, like and expedite it. Similarly, agent for business analyst. So it's not a replacement, but like a developer itself can then do all the things. So down the line, once you have a very you have a performant and very like robust AI agents, then most of the developer will shift into like a rather than basically as a like a framework or tool operator rather than like a actual developer, because most of the things can be done through the integration of different agents and low code. I would say low code or no code, we'll talk about them as well. Key deliverables: the AI solution architect, from code centric output to system centric output. Yeah. So solution strategy is business problem statement. I will talk about some of the this part is good. Let me talk about some of the example in the key deliverables. So vision and just a second. Vision and strategy. I've always created few of the example which I will share with you guys. Let me just skim through so that we understand. I know the first session is a little bit theoretical, so don't worry. Next session onward, it will be very interactive and more on like some of the practical work we will try to do. Just a second. Give me a sec. So some of the I will just give you some of the example in reference architecture. For example, a bank creates a standard RAG reference architecture, LLM gateway, vector DB, yeah, guardrails and logging that is reused across, say, for example, HR boards, customer supports, and compliance search. So idea is, like a create a standard RAG reference architecture, which can be reused across a different solution. Text selection in practical, say, for example, instead of training a custom LLM, and architect may choose a managed foundation model with a light fine-tuned, saving millions in training cost with still meeting latency and compliance. Similarly, uh, regarding KPI and SLA, success is defined using SLA and SLO, not just accuracy. A customer support, say for example, support AI might have a target like 90 95% latency under 200 millisecond, 99.9 availability, and a hallucination rate below 1%. I hope every one of us know about the hallucination rate when we are using the AI model. Yeah. So I will add these examples in slide as well. Yeah. So key deliverables, when we say, for example, we say key deliverables, we are really answering one important question: what value we are expected to deliver to the business, customer, and regulator. Say, for example, in payment systems, deliverables are not just technical output; they directly impact trust, compliance, and customer experience. Yeah, correct. So, vision and hypothesis, strategic alignment, documentation, defining problem, value, and proposition. Capability metrics break down, required AI capability and use backlog prioritization. Data contract is about, schema definitions, quality SLA lining, and governance policy. Operational runbook is about, deployment guides, rollback procedure, and incident response playbook. KPI and ROI model is value realization framework, matrices definitions. Adoption plans are mostly towards change management strategy, user training materials, rollout phases. So this is about, like you can go through this. I think it's a self-explanatory, nothing, very complex. So this slide is about stakeholder management. So we have a multiple in your day-to-day working. You as a AI solution architect, you will always have a different stakeholder. Some of them, which most of the organization will have, is business and product related. Say, for example, product owner. So this is I have categorized into four different dimensions, in which, like stakeholder can be uh, splitted through. So product, business and product managers. SME could be your developer, or even product owner can be SME. End user and customers. Focus here is, UX functionality and value. UX is, like a UI experience, and functionality and value. Strategic or executive is sponsored and C-suite. So your business unit leaders, investment committee. Focus here is ROI, time to value, outcome. Governance and risk, legal compliance and privacy, information security officers, AI ethic committee. Focus here is compliance, safety, and privacy. Technical delivery is where engineering comes in, data science and ML engineering, IT operation and platform team, apps developer, integration, and focus would be, feasibility, scalability, and integration. Stakeholder engagement framework. So this is how you can think of, like as a AI architect. These are the people probably, or this is the model or framework can be used while you are engaging with the stakeholders. So first phase is about like a discovery, align outcome. A key output in this case is outcome map, risk assessment, and NFR documents. So you have to align the outcome, define the constraint, capture NFR requirement. So and along with, like product owner, you also try to understand the detail about the requirement. Co-design is wherein, develop thin slice MVP architecture. So MVP is, minimal viable product. So you don't go into I would say strategic, but rather you develop a thin slice of MVP, which can be achieved faster, and define a success criteria with a partner. Key output is target architecture, data contract, and success criteria with MVP solution. Third is governance. This is where you will navigate through risk reviews and security guardrails necessary for approvals. Yeah. Key output is risk sign off here. compliance review, budget approval. Fourth one is deliverables, execute demo, canary launches, yeah, and manage change control processes. Uh, Key output will be MVP launch. Whatever MVP your solution will be implemented here. Run books and training materials. Operate is post deployment. If there is any monitoring performance scorecard conduct, or if there is any bugs which need to be resolved. Key output will be quarterly QBR, SLA reports, and roadmap update. Translating business need to technical solution. I will little bit go fast so that I can discuss, like reference material at the end, which will be very interesting. I have listed down all the different types of, like models which are used in different types of situations, and how we can also design a system with a low code or no code. So we'll talk more on them. That will be very interesting one. So I will keep some time for that. So translating business need to technical solution. So here we have to map strategy to capability. So basically, you have to create a high level business strategy into required capability and identify specific AI opportunity within the given value chain. Convert OKRs to KPIs, translate business outcome into measurable technical KPI. That is KPI would be your like a software latency, accuracy, and throughput. Process to decision loop, identify operation pain point and map them to a specific AI decision loop or automated enable. Some of the business strategy example is reducing churn by 15% in Q3. This is one of the example you can take it. Technical requirement example are real-time inference less than, or SLA less than 200 millisecond for a given API. Recall rate at the rate top 5 recall rate is greater than 85% for the given ML model. Solution architect could be, like event driven microservice or hybrid edge cloud pattern. So these are the example of, like goal is, like a value realization. Whatever we are spending, we should get outcome in similar proportion. Yeah. Business technical translation framework. So this is where we will talk about how business from business requirement we translate that into the technical roadmap. Yeah. So business context, you'll always get input as a strategic goal, revenue. Say for example, your GM or general manager who heads the department, he will get like a business context. These are the input. So he will get a defined money, and constraint, timeline pressure, resource availability, data reality, like current data quality. Yeah. So those are the input to him. Yeah. As a head of the department. Compliance, yeah, what is a regulatory requirement and internal. Generally these are never boiled down to developers. Yeah. But as an architect you have to understand these business contexts, and you should talk to them and try to come with a solution which at least try to meet the business goal constraint, or even like if some solution needs a very good quality of data. If you think like current architecture, or if we implement them without a good data quality will fail, please feel free to call them at the like a first phase, saying that we have to first improve the data or create a data lake with a quality data, rather than even asking to proceed with the designing or solutioning. Yeah. So it's very important, I think, as a solution architect. And if you think like a compliance cannot be meet, or compliance need give a little bit more time and all, please provide the justification and go back to your business leaders and try to buy time for that. So basically architect bridge is map capability to strategy. That is where like now here is where like you will go through all these reality about your organization, and now you will be asked to provide the solution for that, and that is where you will try to map them. So capability to a strategy, OKRs to technical KPI. OKRs, I hope you understand, right? Very common terms used in all the organization. Every department has a broader OKR, 5 6 OKRs, which individual department want to like achieve in a given year, given financial year. Decision looping and defining NFR matrices, assess feasibility versus the value. Yeah, outputs should be target architecture which is compliant and able to reuse, reference architecture, trade-off analysis, build versus buy. Yeah, so sometimes like given the time constraint and budget, it's always good to propose a buy rather than building from the scratch. The reason is sometimes like because there is a problem statement, yeah, which may not be the same after 6 months. So in order to tap the or monetize that problem statement, you have to think from that business lens as well. Yeah, so you should always choose between build versus buy, cost versus performance, latency versus accuracy. So all these terms, like always analyzed as a AI architect. Pilot, another is like a pilot plan. So always you come with the MVP first. So that is a minimal viable product design, and try to pilot that with a small POC, whether that will be feasible or will be able to implement or not. That's a quick test on like your solution, whichever is you are providing for a limited features. But at least it ensures that you have the all tools, technology and framework available to achieve all the like a constraint which you are putting into that particular solution, be it a NFR compliance or uh, constraint, say for example budget and all. Yeah, so that is where actually you will understand about, oh really engineering implementation will be challenged in this kind of situation, this part. So I think we have to propose a little bit higher time, or you can say this part can be achieved quickly. I think there is a already available AWS solution or cloud solution which we can use as a service, right? So those part is always like you are always able, you will be able to understand, or it will be uh, available at your disposition only when you do some POC on your MVP. So this is a typical AI project life cycle, and this is a difference between typical project life cycle and AI life cycle is where like data discovery and model strategy comes in. Yeah, so these are the two different parts. Other things are mostly same. So in scope and matrices, wherein you define the scope and what are the different matrices which will be key output is vision, brief, KPI and risk register. Data discovery, quality of data, privacy, readiness, data availability. So key output is data contract, quality reports, model strategy, select the model architecture, framework, and platform design. Key output will be target architecture, buy versus build plan, model selection, thin slice prototyping, build end-to-end flow to like a validate feasibility and value. So this is a POC or MVP part, whatever we have discussed here, with a limited features, but test it quickly so that you understand overall like whatever we are trying to solution or try to we have architect, we will be able to achieve. Integration and hardening, I think this is the next part wherein you implement the NFR and security scalability pipeline. This is part of always implementation, wherein you build CI/CD pipeline, prod pipeline, security audit, load testing, and all, many more. Yeah. But as I said, these two part, data discovery and model strategy, is the two part which is introduced as a part of AI project lifecycle. So as a AI solution architect, you will be more considering towards like a model and data. You'll be thinking towards model and data from the implementation perspective, not from like a stakeholder management or ROI calculations, but from the implementation perspective. Sixth is launch, wherein you deploy it. There are different way of deployment: canary deployment or blue-green strategy. If you don't know about the canary, in canary, what we do is, like in first phase, you just open 5% of the traffic, say for example. Yeah. If that 5% of traffic works well in your new system, you open then 10%, or you increase by, like say for example, another 2.5%, 7.5%, total 7.5% traffic. If there is a problem, you switch down your traffic. Then you go back to the 5% of traffic and see if there is a breaches. So that is a canary approach. Blue green is wherein there is a old system and new system sitting together, and you divert complete traffic to the new system. If there is a failure, you divert them to the old system till stability is reached. So in case of blue green strategy, you parallelly build, you will have to parallelly you know keep both old and a new system infrastructure available for at least 3 to 6 months till you reach a stable phase. In canary, you can have you can have infrastructure. So generally in canary approach, because infrastructure is always a constant, right? So in canary approach is generally we used in infrastructure as a code, generally solutioning, which is provided for like a cloud based system. So in cloud based system, you can always add new infrastructure, yeah, on the fly, and you can use part of the infrastructure which will just ensure a limited features to be enabled. Similarly, in case of a blue-green strategy, you can use a cloud solution as well as in premises. But generally, like a blue-green strategy is used for like a legacy system, or like a old system which is available in in premises. Uh, Sometime depending on the budget, I would say generally it's very hard to get the budget for the two platforms, keeping them simultaneously up for like a 6 because there is a cost involved. So generally we go by canary approach. Only say if there is some mission critical, or say for example in payment system, if payments is involved, then you'll get approval. So at the end, you should get approval for whatever budget, and we have two different types of strategy. That is what you have to understand: canary and blue green list. So there should be a go live plan, run book, rollback plan, and adoption communication. Operate and improve. Once you deployed, you have to ensure that there is a seamless operation, and if there is a bugs, or you improve them and redeploy. So basically, like that is where your quality of observability comes into place, and how you manage your service ticket efficiently. Let's go into life cycle. This is a deep dive of the life cycle. You can go through them, yeah, in detail. uh, First is about scoping, then prototype and architecture, integration, hardening, and third is again the launch. So you can just look into the same thing. It has been explained and detailed out here. Stage gate I will talk about here is approval. First is scoping and discovery. This is where you have to get a budget approval and resource sign off. So you have to ensure you have a right amount of resource. Resource means I'm talking about engineers and all who will be involved in solutioning, and budget is approved in this phase. Prototype and architecture, design review board. So you will design your you will architect your solution and present to like enterprise architect forum and get a approval from enterprise architect. So that's a forum basically created for architectural approval. Some of the core activities in this case, as a AI solution architect, will be like a RAG versus agent flow, which kind of model you should choose, security, NFRs, blue green deployment versus like canary and all we already discussed. Uh, Third is about here is I think this is every software which we deploy, we do the production readiness check, do the run book walkthrough, yeah, detail about like how operations will be post deployment operation will be handled if there is a bug, or uh, how kill switches works here. You can also deploy your, if you have heard about like a there are a framework called LaunchDarkly, which helps us in deploying some of the feature based on the switches. Yeah, I will not go much into like engineering part here. Success matrices for the success matrix and KPI dashboard. Guys, please let me know till here, slide number 13. We are able to understand. Yes, no.
Yeah.
Okay, great. As I said, like till first four session, it will be more theoretical, but we will add a use case, business use case. But those theoretical, generally, like the people who are already experienced, they understand the criticalness of those aspects, like say for example stakeholder management, ROI discussions and all. Because if you don't get a first is being approved scoping and discovery, right? Nothing nothing then, whatever good designer you are, right, nothing will happen after this if you don't get this approval. And this is where like stakeholder management, your thought process, your system design experience, your domain expertise, to be very precise, your domain expertise matters here. Yeah, and you are able to sell your like the thought to your business leader, bring in confidence to them that this will be delivered with this time framework. That is where you are accountable. Other part of the people, they may be accountable for the delivery, but you are accountable for the given product. So understand the part, and that is where you try to implement MVP solution rather than going into full-fledged. And at the end, say for example, after a year, you realize after implementing, oh, this has failed because there was a data breach or compliance. I forgot. I was not able to understand that this was the compliance. This part of compliance was also required, and that is where you go, like a prototype based deployment. So MVP is very important. So you have to gradually, like involve your accountability and pass on your accountability to other aspects, other resources involved in the system, like overall end-to-end building. And you will be I would say, like you will be always a collaborator or decision maker between like your uh, because your business leader, they will come with a requirement. You have to understand. Your engineering people will say like, I will implement. They will go with a, say for example, one example I most often see, like, people do the implementation using the best model, and without concerning about risk or like security. But that doesn't work. If your system is not secure, if it's not a compliant, whatever best or whatever like high performance system you design, it will fail. If it will never be productionized. Yeah. So you are the very key point of contact, or I would say key. It's a very key position wherein you will be driving end to end, like a success story of a given product we are designing or solution. Yeah. Success matrices and KPI dashboard looks like, like a model from the model means I am talking about here AI models. So accuracy, F1 score, as I explained about hallucination rate, you know, model hallucinate. It after some time you write, say for example, give a input, it try to give very absurd or similar same type of output. That is called a hallucination. It goes into loop and it tries to gives you uh, unintended output, I would say. I was expecting this, but it. So you can always reduce that hallucination. So there is a matrices involved in that, that is called hallucination rate. Yeah. So and these are all very important, and third is, like a robustness. This is for the, like how robust is your model. Yeah. How it is able to adopt or able to adopt, like a high large amount of data or with a different variant. From the system perspective, P95 latency, availability, that is a SLA, and throughput. From the business perspective, they will always look for the process efficiency, revenue uplift, and CSAT or NPS score. Yeah, NPS is, like customer satisfaction score. Yeah. So this is from the business, and this is very important. If your solution or model or system which you are designing doesn't address this, we are not then thinking from the right dimension. Third is, like a risk wherein data leakage incidents. You will talk. There should be matrices. So these are the matrices, risk matrices. Again, will be part of. You can always implement as a part of, like observability part, wherein you ensure like data leakage incidents are always captured. Bias focus or fairness, safety flag rate, adoption, active users, how many active users are have been signed to your or using your implemented product. Feature utilization is like some of the features which are never being utilized, or it's just like a unnecessary being sitting in the system. Time to value. Yeah. So these are the some of the matrices. ROI, return on investment. Generally, we will talk more detail on that. So this is like a expected versus conservative, wherein you like first is about like from quarterly what are the different uh, this is a cash flow and what is the ROI. Yeah. So it's initially, like while building your system, there will be lots of cash flow, there will be no ROI, but gradually your ROI, return on investment against the cash flow, should always supersede. That is where, like it has to at least not exponential growth. At least it should not be less than linear. Okay. So at least it should always, like growth should be after some point of time, it should be at least quadratic, or say x to the power 3 or something. Yeah, not exponential, but yeah, it should give a good amount of like a return then only you as a solution architect for a given product are called like a success or business success. So these are the value related drivers. So efficiency, like labor efficiency, is about resources which are involved in like implementation. Can we reduce that? So one way is, as I said, like you should think about like an agent, creating a different agent for the resources, which I think most of the organization is already doing to improve output of engineers, revenue uplift, infra licensing, and risk reduction. So these are some of the value related. I will just 840. Okay, so we are SLA management and performance matrices. You have to define SLA, SLOs. Yeah, service level objective and service level agreement. So SLA is wherein you define like for a given features, if customer is using, what is the mm, max, what SLO is, like what is your objective, what is the max time under which like you should always get the output of a given like feature accessed by. But SLA is your real time, wherein like uh, uh, what is in real, when a customer is, your expectation objective was something, but in real when customer is accessing, what is the different timelines under which individual is getting the response, yeah? So you should always try to be aligned with SLO whenever. So this is again a part of observability. Error budget and rollback mechanism implements, like error budget to govern the release velocity and automate rollback policy. Observability stakes. We'll talk about how to define trace matrices, prompts, model output, and guardrails. Yeah. So let's go to the next. So these are the archetype. Yeah, so architecture archetype. So one is like hosted FM versus LLM. Uh, so large language model. Yeah, that, so these are like a direct integration with cloud foundation model via API. So model which is already hosted, you can use that by calling the API. There are multiple available. Now you don't have to basically like in most of the organization, they don't or they don't they are not creating models from the scratch. Yeah, so most of us will be using the model through the API call or using SDK tools. Yeah, simple implementation with managed infrastructure but limited customization. Example could be a POC chatbots and all. Yeah, so rag based model, this combines generative model with retrieval to external knowledge base. Agentic AI or multi agent AI, wherein you create like, so rag based model is generally used for the chatbot based system. Yeah, so common problem is hallucination and data guardrails, and yeah, ensure that the customer data privacy is maintained. Yeah, agentic AI is wherein you define for the given solution, you define different types of agents. We will talk about this in detail when we are solutioning some of the example. You'll understand more into it. So basically, for a given solution, you define different agents, and the agent will do some of the work and pass to the next agent. And each of the agent will be using a different, can use the same or different models to complete their respective task. Yeah, hybrid edge cloud, this basically splits processing between local device for privacy and latency and cloud. So this is about like some part you want to keep it in premise and some into the cloud. Generally 3-4 years back, most of the banking so people, like banking organization, they never keep their database on the cloud. Now they have started with all the guardrails in place. Uh, they were keeping all of the database in like in premise, but in order to use the cloud performance or cloud services, they were hosting just the API and database or like other data related data lakes and all are always kept in premise. Now they have evolved, things has evolved a lot, practices has evolved. Now every even banking organization are building things completely in the cloud rather than keeping in premise. Now most of the places, people are working on most of these migration related project. Yeah, so we will discuss a migration project case studies also, so that you get a fair idea on how to design some of the product which will typically deployed on cloud, some will be mixed of them, cloud and in premise, and some where you are trying to migrate from cloud to sorry in premise to cloud. Event driven services, wherein your like a software is driven by the events at each of the phases. Your software when executing a feature at each of the points in the given flow, it keeps emitting like a event, so that if there is a fall, there is a like a reversal, you understand like I have to reverse to this particular part because till here event was successful and we were able to accomplish this level of like output. Generally it's in uh, this type of event driven system wherein like multiple different types of and different endpoints are involved, or multiple different softwares are involved in accomplishing a given features. Yeah, given say for example a payment goes through uh, from initiation phase wherein like a validations happens and all. Yeah, and it do the input validation what or like count validation, and then emit events. Then it goes to like a order management wherein it creates the order. Yeah, in the system, whether and ensure that the amount transfer amount is available and it is like blocked. Third phase, it could be the execution, while like before execution it can go for the fraud detection, or say for example in the initiation layer itself it can go to the fraud detection layer. Another could be it can go to the sanctions and all. Yeah, and then if everything passes, then it goes to like then uh, it goes to to execution phase. So that's about like a batch versus online system. So batch is wherein like it executes in a you know uh, in given defined time, and online is wherein it is always available on time, online or real time. Yeah, you can always use your solution can be have some part as a batch, some part could be online. There is always in enterprise architect, most of the things are I have seen in online system also there are batch involved for mostly like a data uh, uh, not data, but you can say for like a call end of the day, end of the day transaction consolidations and all those runs in the batch. Say for example you have an online payment system, right, which is online, but at the end they do consolidate for the failure transactions and all. Say for example the IRCTC, which is a online, but like in case of failure it gives you reversal after 3-4 days, which works in a batch. Yeah, monolith versus microservice, I think we are very experienced professional and we already know about this. I'll not go into detail on this. Yeah, uh, you can go through this. Yeah, so monolith is wherein like all different all subsystems sitting together in one instance, It's a single failure, a single point of failure. Microservices is wherein you like you gigantic, like a problem statement, or gigantic, like a system is broken into small, like a single responsibility, single responsibility, serving single responsibility. Failure of each one of the system doesn't mean that entire flow or feature will be failed, but rather, like other part keeps, and there is a resiliency model wherein we say, for example, back circuit breaker is implemented always to ensure, there are many, like distributed architecture which can be implemented in microservice architecture to minimize, like control even after like some part is failed. Yeah. So in today's world, we don't monolith. Yes, there are pros and cons of the monolith. Since monolith, all the systems, all the subparts is in the same instance. Communication between one subsystem to another is very fast. Same within the same instance, right? In microservice, there will always be SLA. If one of microservices is in different, like a network, there will be a network latency and throughput involved. But yeah, at the end, like you are designing a scalable, highly available solution using the microservice architecture. This is a RAG based pattern. Yeah. So whenever you try to, like generate, try to generate, like try to provide solution for chatbot related work, yeah, or agent which is RAG based. Yeah. uh, so this is the flow generally which is, like used. So data source, docs, and database, and it is ingested into pipeline through the chunking. Yeah. And then it is passed to the embedded model, that is a vector encoding. We will talk about, I've created a document also if you guys don't understand about what is a vector encoding in LLM. I will discuss that also. Vector is store and index. So these vectors after encoding, they are stored in the index, so that the similar, like similar vectors which has a behavior are close together. Yeah. And then you have a user query embedding, and then followed by retriever, and then uh, re-ranking, relevancy scoring of these vectors. Yeah. And then retrieve context, then LLM generation, and then guardrail and safety. So this is very important. Till here, like till here, I think LLM generation, if you are not creating altogether a new model, then the still from embedded model till LLM generation is you can ignore, and you can directly ingest your pipeline through the data. Yeah. But this is very important guardrails. Yeah. That is where, like you have to ensure, if your system is customer based, used by customer, ensure that their data is not leaked to other customers. There is a proper guardrail. So if a customer is giving an input in his own chat, then context is defined, and only his data is used to provide the response, not the everyone. So guardrail is very, very important. This is very complex part, and there is always a high chance that uh, like there is a data leak in here. Response caching for the better performance, and you should define the caching mechanism. And then finally, like user response. So this is a basically agentic architecture orchestrator flow looks like. Yeah. So this is a, like a planner agent, then memory manager, verifier agent, tool registry. So tool executor agent, basically API calls database. They register your tools. Yeah, and this is orchestrator. So so this flow is about how we can orchestrate, multi-agent system. Yeah, through this is one of the example. Mostly there could be also sub agents. Yeah, but generally, like a multi-agent is worked in this or planned in this manner. So there is a orchestrator and there is a planner agent, which basically planner agent makes the decision, goal, break down the, like requirements. Yeah, and give the input to orchestrator. Yeah, then tool executor, this tool executor is basically, it has all the like resource available. Basically you can think of, like MCP here, uh, model context protocol. I think as AI uh, architect we should be aware. If not, please go through the MCP protocol. Here this agent will have access to APIs, database, external services. Yeah, and you can define all these through the MCP. You can register to the given MCP. So nowadays, if you'll see, all of the service provider has created the MCP for their services. Uh, Atlassian Cloud has also their own MCP. Say, for example, even Zomato has its own MCP. You can, like order through their MCP. So MCP is basically what it's a command line wherein, like you can say through the chat, like say for example, MCP for GitHub. Say for example, in MCP of GitHub, you can just say you can write down saying that check out or clone this particular repository from here. It You don't need to give the exact command. It will clone to the given location whatever you put in the chat. Yeah, similarly you can do the different operation of the GitHub through the MCP. Yeah, memory manager, because in order to execute a given task, memory is required, because on LLM also needs CPU or GPUs depending on the how complex they are. So you have to ensure like a short term and long term context storage is planned. Knowledge base structured data is available, because from here only it will try to gather the data and put in for, answering the query by the users. Verifier agents, basically, like it verifies output and validates and ensures safety guardrails is in place. So this is a, it can be very complex, but overall, like these are four agents are required for any agentic based system architecture. Yeah. Hybrid cloud architecture, if you'll go through, like cloud has a LLMs, data lake, training ops, small model hard cases are could be like, like a edge on the devices. You can create a edge on the devices wherein you can run the, like a small model. Inference, local cache you can use. Yeah. But most of the large model sits in cloud. Yeah, and it basically works on the data lake, gigantic data lake. Yeah, and there is a training materials for models available which will train the LLM. Yeah. So key takeaway is workload distribution, synchronization, and escalations, and key success matrices. Solution design patterns. These are some of the design patterns. Please go through them. As I said, like a circuit breaker for the resiliency, prompt template and versioning. This is for standardizing prompt engineering as a code with a version control to ensure consistency output across the deployment. Semantic caching is caching vector embedding to serve, like a frequent or semantically similar query. so that your similar query is not always goes to the server and execute the model again and again. Yeah, so this is one of way of optimizes a resource quota enforce. So these are some of the design patterns you have to always consider while implementing your AI solution. Resource quota ensure that enforce the cost and latency budget via token rate limiting and strict architect resource allocating per tenant. Yeah, this is very important. Uh, Otherwise, it will starve other end users. Yeah. So I'll go to, since we are just left with, I wanted to go through the reference architecture. I will take another 5-10 minutes. So this is design pattern comparison matrices. Patterns are prompt caching. Prompt caching means, like whatever prompts you are writing to AI agents. Yeah. So it should always try to cache so that a similar output has a similar input has a similar, mostly aligned output. Yeah. Guardrails, uh, RAG for chatbot and agentic workflow for different agent-based solutions. Latency impact is for prompt caching. What is that? Very low. For guardrail, there is always a latency impact if you add the guardrails, because like you are doing additional work. And RAG based standardization, if you are doing impact is again moderate. Here like latency can be impacted because multiple agents talk with each other. Yeah, in loops and multiple steps. Cost efficiency, prompt based caching, high, it saves and avoids regeneration. uh, Guardrails doesn't save any cost. It's just additional, additional a constraint you have to apply, which doesn't give you input, but it ensure your software is secure. RAG is moderate. Context token cost is involved here. Expensive, high token volume in this case, because agents will talk with each other and there is no human user as such. Uh, it's basically if I'm accessing a feature, then in order to accomplish the feature, human is your agent is interacting with each other, and they can consume as much as talking. Yeah. Similarly, go through other parts. Risk reliability, very important, and implementation complexity. I think everyone will be able to risk and reliability ensure what are the risk involved in prompt caching. So guardrails reduces the risk. Prompt caching, low risk I would say, but it is deterministic. Whatever you are caching, you can what kind of data you are caching, and you can always classify whether we should cache or not. RAG, retrieval error, there is always a retrieval error involved. Guardrail, in case of reliability, it blocks toxicity and reduces the risk. But again, at the same time, it blocks the toxicity as well. High variance and loop stuck states. Yeah. Let's go to technical steel matrices. Architect. Now we will go through the architect part. Yeah. So in case of an architect, you should be very much expert in system design, integration patterns, microservice architecture. These are a must for AI solution architect. Now, this is the expert level. You should have a deep understanding. ML and LLM foundation model, you should have an advanced understanding. RAG implementation, you should be expert. Prompt engineering, you have to be advanced. CI/CD for ML CI/CD pipeline, you should be, if you are aware or you have a little experience also, that's fine. Mostly like this will be done by the developers. A model registry, working model, rest of other part, like you should have a understanding, that's fine. Cloud and infra, good to have a better understanding. At least cloud AI services, you should be aware, expert. Infra as code, at least you should know about Kubernetes, you should be aware. So my suggestion is, after going through this session, please look into which area you are missing, and at least this part, yeah. Microservice architecture, integration patterns, design, this will be covered in the session. But ML and LLM part, right? Foundation models and all, I will just go through, like I say, give you some of them. Observability, as an engineer, you should be already knowing in your 15 plus years of experience. Performance, you should be knowing. Data engineering, vector DB, database pipeline feature. So all the labels are mentioned here. Please try to prepare yourself accordingly to become a very, like a, yeah. Business soft skill requirement. It is must and necessary because you are at a technical leadership role. Although you are a if someone is, can you go on mute, please? Yeah. So business and soft skill requirement, product thinking, strategic vision, executive communication, stakeholder management, risk navigation, change management, you should be aware of. Financial acumen, definitely you should know what is ROI, what is budgeting, yeah. Vendor strategy, build versus buy. Tech leadership, you should have mentored engineering teams or bridges the gap between data and ops. At least in your previous experience, you would have done like some of part, like you would have definitely be part of some of engineering work group, yeah. Ethical judgment. So this ethical judgment, vendor strategy, financial acumen, and executive communication is stakeholder management, risk navigation. These are most of the things I see lacking in the AI solution architect. Career progression, senior architect to principal architect, head of AI, and chief architect. This is the expectation. Yeah. So this is where, like as a senior architect, you will be mostly solutioning and ensure right patterns or right designing are used. Principal architect, you will be owning some portfolio. Yeah. Portfolio means you will be owning the product in this organization. Yeah. Head of architect, wherein you are owning enterprise architect for the given department at least. Yeah. Some part at least, if not entire, there could be, depending on how large the organization is. Yeah. So at least sub department or a department level, you will be heading the architecture. Chief architecture, which focus more on enterprise governance, broader level risk management, industry influence, and transformation. So chief architect, AI architecture is mostly considered as a visionary, thinking from the future perspective, how his or her organization should evolve so that the organization meet the future demand of the industry. Yeah. So key artifact here is, like solution designing, design review, tech depth plan. Here a principal architect, a reference architecture, standards to be followed, risk framework is defined by, so mostly, like reference architecture is standards, risk framework is defined by principal architect. Head architect is, like a tech strategy, budget, ROI, vendor strategy. Chief architect is more on, like a governance policy, organization capability, board reports. So chief architect mostly influence the organization in a broader sense. This influence department probably. This influence sub department. Yeah. And this is a person who works closely with principal architect. Yeah. junior to senior architect role, you can go through, skim through principal and chief architect role, coding, designing, strategy. It has been defined, I think, self-explanatory, and you will be able to go through certification and professional development. Uh, these are some of the certification has been highlighted. I think most of us would have done some of the AI or ML related certification. That's where like expectation is, like you should have some understanding of AI and system design. Yeah. So these are some of the certifications you can do. So key takeaway is, like architect for outcome. So we should always for outcome based, value driven, yeah, ROI based, yeah. System should be reliable, solving the real user problem. Intentional design, choose your architect archetype, whether RAG, agentic, hybrid, yeah. Governance, build reliable safety and cost control into foundation and codify. Yeah. With this one, I will just we are already past 10 minutes, although we started 10 minutes late, but I will just skim through, and I would suggest you guys, just a second. It's a little bit tough for me to go to other part. EdYoda, yeah. Okay, if we'll go at the end of the resources, yeah. So there are other resources which are added. So presentation one and is the same, it's a duplicate one. One of them you can download and it's the presentation. Yeah. Please attempt the quiz. Yeah. Answers is also there. First session is very, like I think we are talking all about a overview. That's why I'm not much, Let me just open this one. This is what I was telling you guys, this is where, can you see my screen?
Yeah.
Yeah, so I will just go through this. Please go through. I think this was not part of the discussion, but I thought to put that as a reference material. So key trait of solution architect, I have put down into four part. Broad AI model knowledge, strategic application, the ability to discern which AI tools to best suited for a specific task to maximize efficiency, solution oriented mindset, cross disciplinary expert. How LLM works, I have kept written down into detail, like how large language model work, tokenization, embedding. So this I think you should understand. Okay, otherwise sometime all these like engineering, engineering uh, I would say keywords, if people say, you should not be blank on them. You should have a good understanding of, at least how LLM, because you are architecting around that. Yeah, down the line, like you don't remember, but at least you should know in detail. Yeah, everything we cannot remember, but you will always go back and I understand. This is a flow chart. I have prepared it. So you can each of the section you can use chat GPT. You can always get the answer, but I have just summarized each of them. What each of the section. Most of important in this case is vector and tokenization. So basically, like a user gives input, so input is broken down into, each of the word is broken down into, one token. Yeah, token is given, like a mathematical value, numerical value, and then those token in then mathematical value for the token is fetched into neural network, and it generates the context which is called the attention, and then finally it generates, like a probability prediction, and it creates a vector. So related, like a token or related, like vectors comes together. Say for example, king and queen will be in closer. Yeah, so whenever you talk from the king and queen, both of them like chatbot will try to answer, or model will try to answer the same. It's very interesting. You can go through, there are lots of like I if I start covering this, this will take 30 minutes. Yeah, this is where I have explained in detail what happens in user input. I'll not go because we are already surpassing time. Okay, so this is beautifully, like I have tried to highlight like what happens in each of the part. This is how most of the time I've seen, like people don't and you will need good, you have to be very good prompt writer, because you will be using AI for analysis as well. What kind of tools, what kind of technology, what kinds of integration, or what kind of protocol will feel in this should be used. So good prompt engineering you should be aware of. So mostly, like what I have seen is, if you can define your prompt in these four different sections: role, task, instruction, and data. Whatever chatbot, whatever like chat GPT or Gemini gives a very good output. Yeah, and this is how like no code or low code solution are created. So role, I have given an example: role, objective, context. Yeah. So basically what we are trying to do is, I'm trying to give a hat to AI, that you are a highly skilled, say for example, Twitter generator, context is strategic with a disruptive. I'm trying to give him more like a detail on like what he is. Yeah, then objective, what you will solve for me. Yeah, and then regarding that objective, I'll give more context how that objective should be. Say for example, if you are a Twitter content generator, I will just say like you are a your task is to produce a viral Twitter product on assigned topic. And in context, I will elaborate more on the topics. Like a context must be aligned with the tone, hooks, storytelling approach, emojis, blah blah blah. Instruction, then I will give a detailed instruction how like you should write the content. Yeah, uh, these are the instruction you should keep in mind when you are trying to. And notes is additional notes or data points which you should refer to give a better output. You can go into detail. I mentioned about advanced. Generally I don't use all these advanced this much. If you master like a core prompt strategy for prompting, I think that is more than enough. And more you practice, you'll become more perfect. Common AI assistant and their models: chat GPT from OpenAI, yeah, Gemini from Google, Claude from Anthropic, Meta AI from Meta. It uses Llama 3, and now chat GPT is using GPT-5. Gemini, recently I think Gemini 3 is also launched. um, Copilot is by Microsoft, and Grok is by XAI. Powerful reasoning models: OpenAI, Google. Yeah, so reasoning models are wherein you need to do the research on some of the products. Say for example, yeah, tasks which need a deep logic and problem solving. Some of the problems, like which need more R&D on the requirement, you should use the powerful reasoning model. You can use it. OpenAI, Google, DeepSeek, XAI, Anthropic, and these are the models. O3 mini models. Google has a Gemini 3. DeepSeek has a open DeepSeek. You can just go and check the model. And XAI, X is like a Twitter one. So Grok P Mini, Anthropic, Claude. Generally, most of the organization is now shifting towards, or have been shifted towards, using the Claude model, which is giving very good output. But other models are also, like uh, depending on like a kind of situation. So this is some of the tools, and these are some of the tools, AI tools available, and what are the contexts in which you should use them Whisper Flow, say for example, AI voice to text dictation. Yeah. Gemini you should use for, say for example, general purpose AI. Emily, AI browser and content assistant. Yeah. Fireflies, meeting transcript and notes. Chat GPT, conversational AI chatbot. Claude is used for general. Photo AI for AI photo editor and generation. Super Grow is for LinkedIn content and growth, social related. Numerous AI is AI for spreadsheet. Yeah. Suno is AI music generator. Notebook LM is AI research assistant. Social Sonic is LinkedIn. So, like using all these, like AI tool, you can create, like some of the apps without any code. Yeah, more and more you use them to create no code solution. I think I have seen many people who are generating lots of finance using, like just no code, using these AI tools. Bolt is AI app builder. So using Bolt, you can build end to end, like application, web application, front back end database. And definitely, it will not be enterprise level, but it solves the at least some part of the problem very quickly. WebP is, like a voice AI in infrastructure for developer. Chronicle is security operator operation platform. Humanic AI is AI marketing automations. Happenstance is, AI networking and relationship. Perplexity, I think it's Perplexity comment many of us would have used. AI native browser and assistant. So using this, you can convert YouTube video, like into, like a summary and all. Open router is, I find very interesting. This is one place wherein you can try to find out which models to be used in given situation. I will just go through this in 1 second. Node GPT, it basically, AI tool that summarizes content. Oh, sorry, Node GPT was the one. YouTube video and PDFs. Yeah. Suno, as I said, like a AI music generator. So this is some of the case study I have put into. We will discuss them in detail, but say for example, banking. This we can use AI for solutioning these case studies. Yeah. Enterprise fraud detections, global scales, tier one. I've just written. You can go through them. Yeah. So these are some of the case studies which can be solved. But let me just quickly finally just
Hello? Hello?